All right. Well, welcome back. Here we are. We're taking a look at section 10.2. Again, we'll split this up into two different categories as we kind of taking a look here. And we got the learning targets that we have here. So we'll kind of be looking at that difference, kind of essentially the difference between those population means. So now remember the conditions we have to have, it's got to come from random samples. Okay, so we have to do that or in a randomized experiment. The 10% condition, we know that each of those has to be there. And then, for the normal large sample, for each sample, the corresponding population is normal or the sample size is large. It's got to be bigger than 30. So for each sample, if the population distribution has an unknown shape and n is less than 30, a graph of the sample data shows no strong skewness or outliers is what we have to do. Okay, so as we come in here, let's look at the problem right away here. We have all the stuff that we have here. A college student wants to compare the cost of 1 and 2 bedroom apartments near campus, collects the following data on monthly rents in a random sample of 10. Only 10, okay. All right, so we have those. Those are some different data that we have here. Let mu1 be the true monthly rent of all 1 bedroom apartments. And mu2 is the true mean of all the 2 bedroom apartments. Kind of makes sense to help us keep track. And so we want to check those conditions here. All right, so here we are. Random. Yeah, it's a random sample of 10 one-bedroom apartments. That worked, okay. 10%, I think probably 10 is probably less than 10% of all bedroom, 1 and 2 bedroom apartments. I think we're okay there. Now, the sample sizes are small. We're not having a lot there. But if we look at the dot plots, they don't show any outliers or strong skewness. So then we're going to be okay. That's the one condition that we have there. So remember, to find that confidence interval, now we're going to have to take the difference of those sample means. And then remember in our packet there, remember we have to find the difference of our standard deviations. And again, remember it's plus. It's always plus in there is what we have there. So again, we use sigma 1 and sigma 2, which are usually unknown. So again, we'll kind of get into that whole idea there of using the standard deviations there. Okay, standard errors. Okay, so here it is. There's our formulae that we have here, and again, our calculator is very handy in helping us compute that as well. Again, don't be afraid to use again the tech corner there is a good thing to walk you through all those different techniques on how to do that. So there we are. All right, so let's see what we got here. Now, the Wade Tract Preserve in Georgia is an old growth forest of longleaf pines that has survived in a relatively undisturbed state for hundreds of years. One question of interest to foresters who study the area is how do the sizes of longleaf pine trees in the northern and southern halves of the forest compare? Now, to find out, researchers took random samples of 30 trees from each half, and measured the diameter at breast height, again, DBH in centimeters. Here are the summary statistics. So we have the north, we have the samples, 30 of each. Here's the mean, okay, standard deviation. So again, we have our box plot that we have over here. That's a good graph that we can use to take a look here. So based on the graph and numerical summaries, write a few sentences comparing the size of the longleaf pine trees in the two halves of the forest. So if we kind of look at there, the shape, now the distribution of DBH in the northern sample appears skewed to the right, whereas the southern seems skewed to the left. Now, there don't seem to be any outliers in either sample. The center, it appears that the trees in the southern half have a larger diameters. I would definitely say that, as 34, or a little bigger than 23, I would definitely say that. The mean and the median for the southern sample are much larger than the corresponding. Now, variability seems to be a little bit more near variability in the north. The interquartile range, standard deviation are all larger in those cases. So we've kind of compared those things. Now let's talk about constructing the 90% confidence interval. So state, we're going to go 90% confidence interval for the difference in means there, where U1 is the true mean in the southern half and U2 is the true mean in the northern half. All right, plan. So we want to do a 2 sample t interval for the difference in means. The random, it's an independent random sample of 30 trees. 10%, 30 I would assume is less than that. And then the normal large sample, since we're at 30, that's our cutoff. So as long as we're at 30, we're okay. So it looks like all of our conditions are met to go forward. So we're going to do it. And again, I'd use the technology here. Use that 2-sample t interval. It's going to give us this confidence of using the degrees of freedom of 55.728. Okay, so using that, we can use that use the technology to do it. That's quite a bit to do on our own here. So we construct a confidence interval here of 10.83 plus or minus 7, which of course is a confidence interval from 3.83 to 17.83 is what we have. Okay. Now, the conclude part, we are 90% confident that the interval from 3.9362 to 17.724 captures the difference of the true means of the DBH of all the southern trees and the true mean DBH of all the northern trees. That's what we're thinking there, okay? Now, again, you can use this, and again, some little cut data, cut shots, screenshots here. When it says for the pooled, choose no, and for the inference about the difference of those, as we're putting those things in, just a couple screenshot reminders here as we're kind of looking at those. So again, you can see how we can get those pretty easily looking at those. Kind of nice when you just kind of put those in and let the calculator do the work for you. Using data and lists from the apartments example, you can always put data as you go in there. You can use list 1 and list 2. That's kind of a nice thing to have there. Again, some other things. Again, look through those tech videos, and we'll kind of walk through example in class as we kind of look at that as well. But those, as you preview these, and if you're on your own, those tech videos listed online for our course are absolutely valuable. They do a really nice job too. The nice thing is you can pause it too, have your calculator handy, and work through those as well. So again, just some reminders here is that the formula for that often leads to errors. They're really pushing. They're saying, hey, you know what, probably a good idea. Use that calculator. Just make sure you're putting down those keystrokes in that step, and make sure that you're listing those different things that come out of there. All right, so we'll get some practice with some exercises on 683. There's a couple of good ones there, 27, 31, 33, 35. Perhaps we could do 1 or 2 of those in class together and get the juices flowing. But until next time, I'm Mr. Boone.